Hey everyone, please remember to vote in the chat for that lecture and how you found it. At 33% of people say average so far, which you all don't like data interchange formats. I'd love to understand what your dislike is. I don't ask that enough, but please feel free to leave actual feedback so that when I look at this in 3 months, I don't think, what was their problem? Or like, what did they like about that? I have no idea. So we're going to move on now to HTTP and Flask. Yeah, that's right. Sorry, you guys are like average. So as like bad means like that sucked. Good means that really like that made me happy, and average is just like that. I think of like the Dave Chappelle thumbs up, but I don't know if that's like a thing that would mean anything to anyone. But okay, so average is like did its job, didn't change my life. Something great. Okay, so HTTP and Flask. Let's get stuck into this. So this is a big topic. This is a big topic. It's big because it's going to affect you for the rest of the course. It's a fun topic. You're not going to get everything straight away, but that's totally fine. We're going to do a little bit. We're going to do a little bit of background, on like what this whole topic entails. So first thing is we need to understand computer networks, right? Like if we don't understand computer networks, then we can't really understand what the hell we're going to talk about soon. So, 1980s, computers were just computers. They just sat on your desk just like your, Nintendo DS or, Xbox, your first Xbox or something. It just sat there. It just exists in its own space. Then computers started getting networked together, right? we're all children of the internet. I don't remember growing up without internet access. Is anyone here old enough to remember dial-up? Because I think I'm about maybe 8 years older than you all, roughly, on average, assuming that you're like a standard high school leaver. So I feel like 8 years, most of you probably don't remember dial-up. Maybe some of you do. But you have networks, computers connected together. Now, the thing is that networks are just a general way to say computers are connected together, right? Like, the internet is a subset of that. The internet is a way where networks computers were networked together on like a global scale, right? Like the whole world can all talk to each other on a big network. But networks can still exist without the internet, but the internet can't exist without a network. So an example of a network is your home network. If you disconnect your modem from the internet, like at the wall, and you leave your router on at home, because I'm sure most of you have a wireless router, you can actually still send messages between computers in your house, right? Like you can send signals. I was doing this yesterday. I set up a Mac downstairs and I was trying to connect to it, and it worked fine. That's like, so yeah, sorry, my point is that networks can exist everywhere, like a home network. Internet's a subset of that, where all the computers are connected together in the world, and then you have the web, right? Or the World Wide Web, as you might have heard it referred to, and that refers to a part of the internet where you exchange resources and documents via web browsers, typically, over like HTTP, which is what we're going to get into. So, we talked about networks. Sorry, I jumped through this a little bit. These are some definitions for you, but I want you to focus on the web definition again, which is a system of documents and resources linked together, accessible via URLs. That's what a web browser does. Very simple. Network protocols. So amidst these networks, whether it's like a home network, the internet, or like the part of the internet where we share resources, i.e. the web browsers, there are different protocols that we use to communicate. And we're familiar with protocols because they're like standard interfaces. They're ways where everyone in the world says, hey, your server's running Linux and my computer's running Mac. How do we talk? How do we communicate? What are these standard protocols? Like, how can you SSH into CSE's machine, which is Linux, from your Mac or Windows laptop, right? Standard interfaces. And with these network protocols, they're essentially just structures and rules, right? Like we all have protocols. Like how do you, like when you greet someone, you come up to them, you say hi, you tell them stuff, and then you say bye. If any of you work retail jobs or whatever, there are certain processes, have a good day, you say to someone at the end, or, whatever it is. These are all protocols you follow. They're systems and rules. Now, when it comes to network protocols, which are different ways that computers can talk over networks, whether it's at home, on the internet, over the web, these are all of the different ones that, these are some of the different ones that exist. Now, networks itself is a very complicated thing, and there's a CSE networks course that you can do if you'd like to learn more about this stuff. But if you have a look at this like application layer stuff up here, you've probably seen some of these before, right? You've probably heard of DNS, you've definitely seen HTTP, you might have heard of FTP, you've probably definitely seen SMTP, POP, and IMAP somewhere. If you're a bit nerdier, you would have seen some things like DHCP. These are all just different ways of computers talking to one another with different protocols. Now, here are just some examples that I've taken, I think nearly a year and a half ago, where like, to understand like, computers can talk over networks by a range of protocols. And when you have a look here, you have this one over here, which is a way of transferring files, which is FTP, File Transfer Protocol. Most of you probably haven't dealt much with that. You have email clients, like if any of you are running like Outlook locally, or Apple Mail locally, or I use Thunderbird, then these systems use things like POP3, IMAP, SMTP to kind of talk to the servers, right? So when I send emails, my computer talks to Microsoft servers, which is what UNSW runs their email on, and it communicates that way. And then you have things like SSH, which is how you're communicating via, maybe command line or something like that. Yeah, Trent's got an example. Uses FTP to put things on his 3DS. Exactly. So there are lots of different protocols. Now, there's one protocol in particular that is applicable to web, which is what we're talking about, right? So like we had this thing about networks. There's my diagram. So all of these protocols I described, you can use all of them on a network. You can do most of them on a home network. And same with the internet, because the internet's really just like a home network that's everywhere. But the web in particular focuses on, sorry for jumping around, it focuses on HTTP. So one particular protocol that's relevant to web is HTTP, and that's the one we're going to talk about. HTTP stands for Hypertext Transfer Protocol, which sounds really, really, really fancy. But in actual fact, it's quite literally just, it's quite literally just, we're going to send hypertext, which is a fancy way of talking about HTML documents. Now, we're all kind of familiar with HTML, probably. Like, even if you aren't comfortable, if I said to you, write me some HTML, and you were like, I don't know what that is, and I was like, have you ever seen, this is bold text? You've probably been like, oh yeah, I've seen that somewhere. Like, these are all HTML things, and you can see them on a web page, on any web page, if you click View Page Source. It's pretty easy to do on Windows and Linux. I think Apple, sometimes you have to click a second button. There's also HTML, right? Because all of our web pages are made up of this funny little language. And all HTTP is a transfer protocol to send and receive a language, which in this case is HTML. And it works because you're on your web browser, and you're in your web browser over here, and you send messages to a server, right? So when you load up a page like WebCMS3, your web browser goes, hey, WebCMS3, I want some information. And WebCMS3 goes, oh, here you go, here's a page that you can load. And there's this kind of like chatting back and forth that happens over web browsers, and that's what they do. They use URLs to communicate from your web browser to a server, and then the server sends you back some information, right? So think about it like you're going to pick up some food or something like that. You come to a counter, you say, I'd like this, and then they give something back to you. Sometimes they'll give you exactly what you want. Sometimes they'll give you what you don't want. Sometimes they'll say there's a problem with what you want. But that's the kind of exchange that happens, and that exchange happens via HTTP, because that's why all these URLs here have HTTP at the front of them, because what we're saying is that's the kind of protocol that we are communicating over. We're not going to get into HTTP requests and responses. I put this in originally into the course, but the more I teach it, the more I think, it's kind of not really relevant. But remember how I said before, where you just say, you walk into Baker's Delight or something, and you say, can I have a loaf of wholemeal bread? And then you get back a loaf of wholemeal bread in a bag. It's like you can really equate those very simple understandings of, request and response to HTTP, because this is something your web browser would send. Your web browser might send something like this to a server. It's like, hey, here's my request. I'd like some stuff. And then the server says, here's some stuff. And then you send some stuff back. So it's a very straightforward thing. I'll answer one question. I'm not going to go into any depth with it. Girachan says, what is HTTPS? HTTPS stands for Hypertext Transfer Protocol Secure, or secured, I'm not sure. But basically a while ago, people figured out that the problem is that when you make a request, like when your web browser sends a message to a server, right, it actually sends this information, and sometimes you might have some sensitive information in here. Like sometimes you might also, like, as part of your body, you might say, like, your message is like, my password is Hayden Rocks 2015 or something. And when you're communicating via these unencrypted channels, anyone along the network can listen, right? Like if you're the home router, your Telstra internet provider, sending it to your CSE's Optus internet provider, to CSE's server, everyone along that path can actually see what you're sending, right? So HTTPS is essentially HTTP, but it encrypts everything that you send. So all the messages you send just are gibberish to people who try and intercept them in the middle. Which is why, this is why that whole internet privacy debate's really interesting, because the government's like, when the government's saying, oh, we're gonna log and track everyone's internet usage, people think, oh my god, they're gonna see the messages that I send on Facebook or something. And it's like, no, they're not, because messages like on HTTPS, everything I'm doing here on WebCMS3, like when I send a payload, like I update a resource or I submit a notice or something, all of that's encrypted. But the thing is that on all these requests, you actually have some common information, which is like, what URL are you accessing? Where are you from? What time did you do that? What web browser are you on? All this kind of stuff. And that is always sent in the clear. So like any smart person who was like a bit hacky could probably, if they really wanted to, figure out what URLs I'm sending data to, blah, blah, blah. And anyway, so there's this whole, it's an interesting topic. You're all computer scientists and you're going to study ethics and stuff eventually. So I would really encourage you, if you have any curiosity, to go and follow things like, cybersecurity news and computing policy. Because, again, when the government say to you things like, oh, we don't know. Like when the government say, oh, we don't record your phone calls. I think there's this old joke that's like, we see you made a phone call to a prostate cancer hotline at 2 a.m. every night for a week, but we don't know what you talked to them about, right? Like that's the old joke about metadata. So I'm not going to go into that because it's super tangential to the course, but it's interesting stuff. Okay, that's HTTP. It's a way that your browser, like Chrome, Safari, Firefox, Opera, whatever, talks to servers, right? They exchange information over HTTP. That's kind of background. Now we're actually going to get into the hard skills that you kind of have to be familiar with. And that is building a web server. So if you haven't already kind of got the impression, what you're doing with your major project is you are building a web server. And that means that you are actually going to build something that a web browser can talk to, and you will send information back. And we're going to build a really simple one together, and we're going to use some Python libraries to do so. So, I've got this file here called flask1.py. Now, there's a lot of random things to unpack in this file, and some of it we're not going to go into too much depth of, but Flask is a Python library that allows you to run web servers. right? So using the Flask library with Python, you can actually create your own web server. It's really cool. It's not really that easy to create one that you can have anyone on the internet access. That's a bit harder, but you can do it like in your own little local environment. Bronzy is cool says, is the web server going to be in Python, or do we have to learn another new language? No, it's going to be in Python. We don't. We're done with Python. We're learning Java this week. You'd all hang me up on Scientia somewhere. No, it's all in Python. The reason we talk about networks and HTTP is because it's essentially using Python to send and receive HTTP requests and JSON, right? So HTTP and JSON are like the prerequisite to just using Python for this stuff. So Flask is a web server. How this works is that your web server file is kind of made up of a few key components. The first one is the import and the setup of the server. This one's kind of always the same, right? This line makes sense as an import. The second line here is a little bit weird, but don't worry about it. It's basically creating a web server. And then this last line here is actually running the web server, right? So line 2 creates a web server. Line 15 runs it. So if I don't actually have this line here, and I run my file, python3 flask1.py, it'll do nothing, right? It's like running a Python file with just function definitions, but sorry. It's so loud. Heavens. Okay. Yeah, it's like running a Python file with no code that actually runs. So this line here, app.run, which is inside the if name equals main thing, that's actually what runs the Python server. And then this middle bit here is not really necessary yet. So if I have a simple file like this, and I do this, I have created a web server that does nothing, right? So there is an actual server running on my VLab machine here that is running on this IP address on this port. Don't worry about ports and IP addresses. Think of it like a URL, right? This is just a URL that's running. And it doesn't do anything, but it's running, right? I've created a web server, I've started it, but it does not do anything. So I'm going to close, and the way this web server runs is that basically when you run the Python file, it just runs forever until you stop it. So this will just sit here forever until the computer's shut down or I stop it. And I can stop it just by pressing Control-C. Control-C stops the web server. And I can run it again, Python Flask, and it's running again, and I can stop it. Now, what did we say the web was? We said that the web is a way of exchanging resources via URLs. So when we're building a web server, what we're essentially doing is building a system that is able to have someone access a particular URL. So we're essentially building a library of URLs, right? Like think about Web CMS3 or something. You know, you've got like course outline, which is /outline. You've got forum, which is a redirection. You've got lectures, which is /resources /something, and you know it kind of goes on. There's lots of different ways. But it's all URLs, right? I'm saying this URL, I want that information, and then you're like, okay, here's that information. So that's what we're doing with a web server. And what we're going to be doing with this web server is putting URLs on there. And in fact, this is the first URL I'm going to put there. And the way this works is that I create a function, and that function returns something. What it returns is what the server returns to the user. And this function is called when a user accesses this particular URL. Right, so this app.route thing here, that's always the same. This first line here, the only thing that changes is this text, and it depends on what URL you're interested in. The name of this function does not matter, and don't worry about the @ syntax. Again, there's a lot of stuff here that's kind of like, yeah, just copy this for now, and we'll slowly start to make sense of it. And then all it does is return the text hello world. So now watch this. When I run this, I get the exact same thing. It just says running at this IP address in this port, this URL. But it's actually capable of handling one type of URL now, right? And I'll show you that. So let's open up Firefox, because I like Firefox. So with Firefox here, we said that it's like on this URL. Okay, so let's copy and paste this URL into the web browser. Let me just make this a bit smaller. Bam. Oh no. Okay. So I've got this error now, which is like, I can't be found, right? So the web server's running, right? So it's there. It's like anyone who contacts this domain, this IP address and 5,000, it's like I will receive requests from that and I will figure out what to do with it, right? And here, what we're saying is that if someone does /hello, we know what to do with it. And if someone doesn't do /hello, then what's going to happen is it's going to crap its pants and be like, I'm sorry, that doesn't exist. I don't know what the hell you want from me. So, that's funny. Yeah, so watch this. If I go here and I go /hello, I actually get this file. See that? /hello. I actually get hello world. So what's happening here is that my web server runs on this address. And if someone does /hello, then what happens is it talks to my server and my server's like, someone's made a request for /hello. I know what that is. It's right here. So my function, I have a function to deal with this, and my function will return hello world. Hi, COMP1531 friends. So I'm going to update that text. Okay, now I'm going to run it again. Okay, nothing's changed. Now the reason nothing's changed here is because I've saved my Python file, but what I haven't done is restarted Flask in this case. Like I haven't restarted the program, right? Because like once you hit run on the program, it runs the program as it stands right then and there. But if I stop it and then I run it again, I stop the server, start the server, and then I refresh the page and I get this here. And you can also see that the server is just kind of doing a print on the console. Every time I load this page, you see it's actually saying that someone tried to get this particular URL at this time. So I'm hoping you're understanding now that like all the web is basically it's a system whereby you can use URLs to access resources. That's all it is. The internet just happens to be, the World Wide Web just kind of happens to be the thing that matters, which is the web on the internet, so that you can actually use it everywhere. Here's a couple things though. Watch what happens if I open another terminal and I navigate to 1531 like this, and then I'm going to go python 3 flask1.py. I get an error here. So I've tried to run my same server again, and it says error, address already in use. Okay. Now why does that happen? This happens because all servers have to run on a particular port. Ports are a bit of a weird concept, but basically it's like, I mean, a computer has like a whole bunch of ports. Think of it like it has a whole bunch of pigeonholes or whatever happens. And it says I can't do it. It's already in use. Now the reason for that is if I stop my server, I can actually specify the port I want it to run it on with Python. I can say port equals 5005. And you'll see when I run this now, it's now running on this URL :5005. So if I try and load this, it fails. It's like I can't establish a connection to any kind of server like that. But if I do 5005, it works now. And you'll notice when I try and run the second server, it says, sorry, the address is already in use. That's because on any computer, you can only run a server, like a web server, on a port once. Like you can only run one at a time on a port. Now, obviously, you can run many on a port. Like you can run a web server on all the different ports. I don't know how many ports. There's like 10,000. Like you're not going to run out. You tend to do above 5,000 or something like that. But we're not talking about ports. It's not network theory. The reason I want to flag this to you is I've said that you can only run one web server on a port per computer, right? So every computer with its own network card has a whole bunch of ports that you can run on, right? So I just want to explain something. What this means is that if you're on your own laptop at home, right, your physical laptop, not CSE, right, not VS Code SSH, like you're actually running on your own terminals, then you'll probably be able to run your servers on any port you want because it's your machine. But here's a quick crash course in something important. So the way that CSE actually works is that in CSE, there's actually eight VLab servers, right? Because there are a handful of people here who use VLab. And they all have different names: VX1, VX2, VX3, VX4, and I think they might be getting more. I don't know, but basically what happens is whenever you connect to VLab, or in fact, there's like other servers as well that are used for like VS Code, SSH, and other stuff. But imagine that there's like a finite set of servers that actually exist in CSE. And when you connect to VLab, you're actually connecting to one of these servers randomly. And many students can use the same servers at the same time, right? Like I can be using VX8 and you can be using VX8 and we're like logged into our different accounts. But these are just computers, right? You can have multiple logins at once. You can actually see what server VLab sent me to today, which was VX8. It's actually written right down here. And the reason that's important is because sometimes you will find that your Flask server does not run because it says address already in use, but you'll be like, but I'm not running it. It's the first time I've run it today. And sometimes that's because someone else on your particular VLab server or other server is actually using that port already. And just to give you an example, right? So a bunch of you here in the lecture, try to connect to VLab by opening up, open up your VNC thing. And when you connect to VLab, right, instead of connecting to vlab.cse.unsw.edu/5920, connect to like VX8 directly. So you can do something like this where you say, I want to connect to VX8 directly. Right, so if you do that, it'll load up VLab for you. And while you're on VX8, if you go to this URL here, right, you will be able to connect to my server because we're on the same machine, which gets to a question that Selena asked, which is, if you open the web browser not on a CSE server, it will raise an error. And the short answer is because when you run a web server, without doing a whole bunch of configuring, it only runs on your local, like think of it, it only runs in your little local machine or your home network, right? It doesn't run on the internet. So just because I start the server here doesn't mean you can access it. So in general, you can only access a server, you can only talk to a server with a web browser on the machine you're running it on. This also kind of means that if you run a server on VLab, if you run a server on VLab, then you can only really access it via URL on VLab. Someone connect to VX8. Just open up your VNC client. I'm sure some of you do it, right? Some of you must use VLab here. You can still do all this locally. It's just I'm showing you on VLab because VLab's kind of the common standard. If anyone connects to VX8, you just VNC on this URL. What? VX8? Really? Oh my god. Why is that? Oh, is it just vx4.cse? Oh, don't do the VLab part maybe. Well, I don't know. Or what you can do is you can just connect to VLab until you eventually get VX8. You can just like do that and you'll get VX4 and eventually one of you will hit VX8, I'm sure. So don't do the VX. Maybe they don't let you do that anymore. Maybe they've changed that. Yeah, anyway. So you can see that this is actually CSE randomly assigning you one of the servers. They'd have load balancers that would figure stuff out. Or maybe even better, someone tell me a VLab server you've connected to and I'll connect to it. It's just a cool demonstration, so. Got it, okay. So someone's on VX, okay, well, Miguel's on VX8, so we'll just stick with that for now. But if Miguel opens up a web browser, so he's at home somewhere, so that's Miguel connecting to this page, right? So that's what those, and you'll notice more requests pop up if Miguel kind of presses refresh and stuff. And if other people end up on it as well. That's actually you making a request to the Flask server that's running, right? Because we're all on the same physical machine right now. So getting a web server on the internet's a whole different topic, right? But getting a web server running on your own kind of at home or on like one machine is, that's easy to do. You can do that with 5 lines of code and pip 3 kind of thing. We already installed Flask as part of the main pip3 install when you did the lab 1 Python hello, so that's pretty straightforward. So, we're loading, these pages are, I don't really know what the Shrek thing is. It's so random. I think there must be a static folder or I don't know. No, I have no idea. So that's everyone connecting to my Flask server, right? So you can do this. And then I got a question from Miguel again, which was like, hang on, so if there's other teams running using VLab, we could theoretically use other teams' programs. Yeah, you can. I don't know how much that would help. Like what that would do for your life, but you could, in theory, do it, yes. So just to expand upon our Flask knowledge here, you know, if I can actually make more URLs, right? So we know that Flask is just a server that we create, it's a server that we run, and then it's a whole bunch of URLs that are accessible. So if I actually change this to like hello and goodbye, and I say hello, goodbye world, you're awesome. Then you'll see if I stop and restart my Flask server, oops. Oh, this is a common mistake actually. Remember how I said the function name doesn't matter? Like you could call this like one pineapple, oops. You could call this one pineapple pizza. It really doesn't matter because it will just use the URL above it. But they do have to be different functions, like different names. So I'm going to run this again, right? And I still have my hello, but then I have my goodbye as well. So I've like, now I'm loading like 2 different pages depending on what the URL is. Okay? So we're providing resources via URLs. Now I'm just going to minimize this for the moment because otherwise people will just keep clicking on it and it will distract everyone. Let's just quickly keep talking about Flask generally. So the thing is, Flask is a web server and you can do more than just return text, right? We can return text, we can return HTML, we can return images, we can even return JSON, which is kind of a big part of what we're going to be doing. So I have this second server here called Flask 2, and on this server you can see that it's very similar, except the route is in /image. The URL is /image instead of /hello or /goodbye. And as part of this route, what I'm actually doing is I'm saying, you know what, when someone calls this route, can you please send this file? So instead of returning hello, right, I'm instead returning this send file function. Now, like, what is this? Well, send file, this is not something you're going to really need to do much, but send file is a function that is built into the Flask library. See, we're importing it from the Flask library. That essentially, if you just give it a file, it will package it up and send it back to a user for you. Like, it'll send it back as a response. You know, so see how I've got this, where's cat.jpg? I thought I had let's find one. Cats. Oh, let's find one of my favorite dogs on the internet. Oh my god, VLab is dying. Ah! Done something terrible. Okay, so one of my favorite dogs is called Eris or something. I don't know how to pronounce this name. It's just a funny dog because it's got a big nose. This is a dog, and I'm going to save that as let's see, lecture code week 4. Call it dog.jpg. Now, if I was to just like have a server here where all it did was just return, you know, say like dog.jpg, right? I'm not really returning the actual JPEG. Do you know what I mean? What I'm returning is just the text. Yeah, just literally the text dog.jpg. So this Flask server is on port 5000, right? /image. If I don't do /image, it just says it can't find anything. If I do /image, then I get dog.jpg. But I actually want to send the file. So I use Flask library to send this dog.jpg file. And then when I restart my server, because I've made changes to my code, I get the dog. Right, so now you've made a web server that will actually return you that dog, and other people, no doubt, will fairly quickly find the dog and receive the dog. Cool. Okay, APIs, Postman. I'm just quickly remembering what we're going to do. Great. Okay, we should be able to get through this today, which is very exciting. Someone says, can we copy the link to the pic instead? I don't know what that means, sorry. I'm just not sure what you're really asking there. Okay. Just lost the window. Can you copy the link to the picture? You can copy the link, but the link's just going to be to this here. Like if I copy the image location, I'm just going to get that. So as soon as I stop running my Flask server, no, if you wanted a link from the internet, then I'd have to actually give you that link from the internet, right? Like there's a different, like you can send someone a file that contains the URL of the dog, or you can send someone the dog file itself, right? We'll get into all that kind of stuff later, I think. Now let's just move on to the last part of here, which is Flask Reloading. So when you open your terminal, there's a few cool things that you can do with Flask, but the main one I want to talk about is the debug flag. So if you have a terminal open, and I'm pretty sure you'll have to do this per terminal when you load it up, but like if you load up a terminal and I say export Flask debug equals 1, I'm kind of like setting this magical environment flag on my terminal that will flash. And what this will do is when Flask runs, if it sees that this kind of thing exists, if it sees that you've run this command in the terminal, it will automatically like reload your code when you make file changes. So let me show you. If I run export Flask debug, and then the way I have to run Flask is a little bit different. I have to do the python-m Flask, right? So just those two lines. This is a bonus tip for people. When I run Flask now, you'll actually see that it's running in debugger mode, which it means a couple things. One is it might actually give you more information, but also watch this. If I change this URL from image to like image2 and then I hit save, it didn't. Okay, that's a shame. Should have detected that. Maybe I'm doing something wrong today. Image 2. Oh, it did it. Okay. Yeah. Okay, sorry. For this to work, sorry. So all this stuff at the bottom here is trying to show you how do you make Flask automatically reload itself. Right? Because you might want to do this. You might be making quite rapid changes and you don't want to cancel and restart it. So you have to do three things, which is first one is you actually have to put this line to give it the name of the Flask server that you have. So in this case, the Flask server I'm running is called Flask2. So I have to go Flask2. Done. And then I run the command I ran before, which was Flask debug. And then I run the third command, which is Flask run. And I think this should work. Hopefully. I've probably done something weird. Okay. It seems to be doing it, though, slowly. I'm not really sure why it's so slow. Like, very strange. Okay, that worked. Basically, if you do that, see how it says it detected a change in a file and then it's restarting? So if I was to say create a new route here and then just make that image 5 and then do this, if I press save now, it says detected change and it will reload. So that's just a cool tip for those who kind of want to have their Flask stuff automatically reloading. Fanguse asks, what's the point of the MIME type? There's a lot of things here that are tangential, but that's basically telling the web browser what type of image it is. So that you're not just sending a file, but you're actually saying, no, this is an image file. That's how you can interpret it. Demit says, can we use Flask on VS Code? Like, will it be able to load the file on our local server? So, if your Flask server runs on CSE, if it runs on a CSE server, you'll have to use VLab to access the web browser. If you run it locally, then you can load up the web page locally. Right, so this means that if you're actually using a local terminal, then you can load up the web page locally. But if you're using like VS Code SSH and you're doing everything via SSH on the CSE machines, then you'll have to have VLab up to look at the web page. Okay, there's more stuff about Flask. You can go and learn this. There's lots of different versions on the internet. So go check that out, basically, if you want to learn more. Millie says, do we have to specify the file name? No, you don't, because you did that in this line here. This export Flask app equals that. You don't have to specify the file name. Okay, now we're getting on to how we're actually going to use Flask besides returning images of dogs and text, which is about APIs. So it's hard not to get into it too much, but like, what is an API, right? So this falls into our network topic, which is, this is kind of the critical part. An application programming interface refers to an interface exposed on a particular piece of software. Okay, what the hell does that mean? Let's keep reading. The most common usage of APIs for web APIs, which refer to a contract that a particular service provides. The interface of the service access, blah, blah, blah. It's kind of boring. But basically what this means is that, like, I was looking at this product yesterday or on the weekend called Assembly Payments. And this is an API, right? You see APIs all over the internet. And what APIs are is they're basically a collection of routes where you can do things. Like you see here, it's like, what's a good example? It's like charges, sure. So this website is basically saying, oh, if you call this URL, I will do something for you. If you call me this and give me that, I will give you something in return, and I'll cause an action. And if you call this, then I'll do the same kinds of things, right? So it's essentially, it's a contract or an interface. And I'm hoping that you're starting to maybe connect the dots around iteration 1 and how, like, that's like the interface you had in iteration 1 could be an API. It's this black box which essentially says these are the different resources or functions you can call, or URLs, functions, URLs, resources. Give me this, I'll return you this, and I'll have these side effects. Give me this and I'll, like, that's what it is. It could be a document of capabilities, which might be functions or URLs. So that's what an API is. And generally, there's a lot of web APIs out there. Ones like this, where you communicate over HTTP. You're making a request to HTTP URLs and you get stuff. And this is an example of a very large API. And there's tons of APIs around the internet. So whatever. So why does this matter? Well, we need to understand it first, and then we'll tie that back into how we're going to use it. The reason APIs matter is because the way a lot of modern web pages work is that you, trying to think of an example. There's a merge request here, right? And here's an example of a merge request. This is some project stuff. Every time I click a page and I load a new URL, I'm making a request to the server to get a document back. But then typically, when I do subsequent actions on the actual web page itself, right, I'm actually communicating with an API. So a really classic example is you've all loaded up Facebook Messenger, right? You know that you have to load the page first. But then after that, you can actually send messages and receive messages from your friends without reloading the page, right? And all of that stuff is happening via APIs. It's all happening via these like interfaces that exist where your web browser can just chat to the server quietly. When you hit approve on a merge request and the page doesn't reload, something just happens. That's actually your web browser communicating with the server, right? Through an API. When I click close merge request, I mean, in that case, it's a little bit different. So APIs are really critical to understanding things, because after we load a web page, we're typically going to be trying to get extra data and interact with web pages in more ways later. And that happens via an API. Now, if you think of an API as literally an interface, like a .h file in C, the interface from iteration 1, all it's doing is listing a series of capabilities, right? A series of functions, a series of things it can do. Like if you go back to the actual, project itself and you look at the interface table, it's literally like, these are the things I can do. I can register a user, I can invite someone to a channel, I can create a channel, I can send a message, I can edit a message, I can set an email for a user. These are all things it can do. When we build an API that's based on HTTP, right, which is what this API I showed you is here, right? Any APIs that use HTTP, we tend to call these, we most often refer to them as RESTful APIs, right? That's just what it's called. And a RESTful API is one whereby you group all of the functions or URLs that you're using into 4 buckets called methods. And we refer to these 4 methods as CRUD. And they're called CRUD because the 4 operations we're interested in are creating, reading, updating, and deleting. Which makes sense, right? Like if you think about anything you do, you're generally creating something, reading something, updating something, or deleting something. It's a very common way to do it. And in this world of HTTP, we refer to these 4 operations. These are just conceptual names, but the actual 4 methods we use when we're actually programming are post, get, put, and delete. And you can actually see these here on this API too, right? Like see how this one here is post? This one here says post. If I look at some other ones, this one here says get. If I look at some other ones, there's like post and get here, and then patch, and that's a different one. And you see this one here is delete, right? So we've got like, there's the 3. I don't know if we have put, which is the other one. There's very long reasons why put is not very commonly used nowadays. But I won't get into that. But you know, these are different ways you can actually interact with something. So I'm going to be talking about this more tomorrow because I want to release the project first, but because I'll push this to your repo today. But in essence, your iteration 2, which we will talk about tomorrow, is basically going to be very similar to your iteration 1, except now instead of writing functions that do stuff, right, you're going to be having those be URLs, right? So instead of functions, you have URLs, and people are going to be interacting with those URLs just like they might be with your functions, and they're going to do the same things and more, right? So like instead of someone calling a function for auth register, it'll be like they call a URL to register, for instance. Yuval says, what would you do for like updating someone's password on websites? Would it be put? It would be put or post. In the real world, put's not really used much. Ask me about that in a week or 2 when we're running out of content. But in general, for the conceptual sake of this course, it's like put is the way to do it because you're updating it. You're not, and we'll get into these 4 methods in a sec. So, this is the real meat of today's lecture, which, because I don't know if we'll get through all of this. No, we won't. But that's okay because we've got tons of time tomorrow. But I just want to show you an example so that we can really put this in practice, right? Because you need to see this in practice probably to fully understand it. I mentioned that CRUD is this process where we build a web server that has these 4 methods: post, put, delete, and get. But how, why would we actually do that? Why is that particularly interesting for us? And I will show you here. We've got this file called crud.py, right? So let me close some of these. Crud.py. Now inside of this, I have a little bit of extra stuff. I didn't include everything on the slide, but you see, I've actually got 4 different URLs here. I've got URL 1, 2, 3, and 4, and you can see that they're all of different methods, right? They all have different CRUD methods, right? So this one is read, this one is create, this one is update, and this one is delete. And they're all going to kind of do different things. Now, what's really important to kind of flag is that HTTP methods like get, post, put, and delete, these are kind of like function names. You don't need to follow the rules with function names. You could call your function, you know, giant llama. And your code will function fine, but you tend to follow conventions so that people can make sense of your code. And it's a similar thing here, right? So these methods, labeling this does not do anything particularly special. It doesn't magically allow you to create stuff. Like, you have to do that yourself. These are just here kind of to help other people understand what your stuff does. But I'm going to get rid of these bottom 3 for a sec, because they're probably just going to confuse you. Bottom 2, sorry. Let's have a look at these 2 very straightforward HTTP routes, right? So we're familiar with Flask servers. You know that if I run here Python 3, and just for a sec, if you could all not do the request, that would be good. If I run Python 3 CRUD, you'll see that my server's running on 127.0.0.1, and I can, if I try and access that, I get nothing again because this page doesn't exist. But I've got these two routes here called 1 and 2. Now, it's a little bit hard to like articulate, but because there's a lot to unpack here. But if I try and load /1 here, you'll see that I actually got a response of this, and let's get rid of these requests for a second too. So I just say 1 Hayden, 2 is Smith, right? I refresh that page. You notice that Flask refreshed for me. It can be helpful when you have the debugger on. So let's have a look at what this did. We know that this route was accessed, URL /1, and we know that this function returns something that's given back to the page. Now, you've seen in the previous example, we could just change this to hello. So that actually, like, what it does is it just, you know, literally just prints hello. And if I look at the page that it returned, it just prints hello. But I don't want it to do that. I want it to actually return me some JSON. Right? So if you have a look here, this is what the page returns. Just this text. Now, we learned about JSON in the previous lecture, where we learned that if you give JSON dumps, this is just imported a different way, but if you give JSON dumps some kind of data structure, some series of lists and dictionaries and numeric values and stuff, it will convert it to JSON for you. So what this route here has actually done is it has given this to me in a JSON format. And I could add more to this if I wanted to, right? Like I could add this as like URL like that. Now, one cool thing you can do with Flask is that there is a library property called request. And on request, you can get the arguments from the URL, and I'll show you this. Basically, like I won't bore you with the theory. I'll just show you in practice. You can do something like this. And you think like, oh, that looks the same. Well, it looks the same, but it's not really the same because now I'm actually loading variables from the URL. So you have to understand web servers as these big input-output machines. That's all they are. They take input, they do something, they output. They're really just glorified functions because that's all a function does, right? A function takes in some parameters, it does something, and it outputs something. Just we're doing this on a slightly different scale. And you can see instead of the function just kind of like taking in parameters here, like, you know, first name and last name, it has to come in a different way. And in this case, the different way it comes in is via the URL. So the data that I'm actually loading into these variables here comes from this URL. In fact, I could change this. I could change this to like llama. And you see that that changes now, right? So this is how I get data from the URL. So what's different about GET requests compared to all the others? Because right, we said there's 4 CRUD types, and GET's a bit different. With GET requests, the data that you receive is passed in via the URL. Okay, like this, and that's how we can access it. So if someone, you know, wants to get some information from me, and they want to, like, if you want to call a function and you give it some arguments, this is kind of how you do that with web servers. You put it into the URL, and the web server can extract that as variables. So I could do something like this, right? First name equals that. Then I could say, you know, last name equals that. Yeah, exactly, Yuval. So that's my server. I'm getting in data this way, and I'm sending it back out that way. And that's GET. Now, the other 3 types of HTTP methods are a little bit more, require just a little bit more of an understanding. So I kind of feel like I need to jump to talking to Flask first. And we will finish this off tomorrow. The thing about web browsers is that web browsers are basically GET request machines. They're designed to make GET request to servers in general, right? Like when I say web browser, I mean this URL bar up here. Everything you type into this URL bar is sent to a web server as a GET request, right, of type GET. And I'll show you what I mean. If I try and access here, like /2, it says method not allowed. And basically why this is saying this is if we have a look at the terminal here, you'll see that every time I refresh this, it's like I tried to get to, because all of the requests coming from web browser URLs are GET requests, right? So this is just not working. Only the ones that actually do the GET requests work. Yeah, you will need to rewatch this, but again, like we're going to go through this tomorrow, and then we're going to go through it. Like Flask will be part of labs and lectures and whatnot. And iteration 2, I think you have 4 weeks with. So like, again, new concept. If 30% of it makes sense, then just through continual exposure, you'll be like, oh, okay, I'm starting to get this now. So what I want to quickly touch on today, and then we'll loop back to it tomorrow, is how we actually communicate with Flask. And there are lots of ways to talk to a web server. There aren't just web browsers. Web browsers is an obvious one that we've started with today, but there's actually another way that developers like you do use and will use. And one way to do that is to actually download a tool, which you can download. I'll show you right here. If I just open Chrome, oops. If I just go here and I open Chromium, yeah, sure. And I go to, I think it's like, I don't know, apps. If I go to apps here, I've already downloaded this one, but it's like, if you just Google like ARC app Chrome, you get this like top link here, which stands for Advanced REST Client. Now, what do we remember? We remember that the APIs we're designing are called RESTful APIs, right? REST means CRUD, it means like post, delete. They're all kind of interchangeable. And you can actually install this on VLab or your local machine. You don't need to install a program. It's actually just like a browser add-on. So I've already installed it here. So when I launch it, I'm going to get this pop-up, which is basically a tool. And it's a tool that you'll probably be using a lot throughout the rest of the course. And what this tool does is it allows you to... This is not good. Hello? Hello, hello? Oh no. Why is it grumpy? Oh, this is annoying. I don't know. Let's try it again. Chromium. Apps, ARC. Oh, we had this problem in a final exam once. Remove from Chromium. Okay, I just deleted it. Let's try and install it again. Add to Chrome. Add app. ARC. It's probably an old version, might be a guess. Okay, so we got like 5-ish minutes left, so I'll just show you this quickly. This is, think of this as like, this is not really like a web browser, because the point of these clients here is just to allow you to talk to a web server. So you know that I have this web server running here with this like 1 and 2 thing. So rather than use a web browser, I'm going to try and talk to it via this. So we know that there's these GET requests, right? And I'm going to type in the URL here again. HTTP, all of this, 5000/1. Now, if I click send, it's just like sending it in a web browser. I'm going to get a response, and these two variables are going to be null, because what happened was that when this page tried to load, it did not find these in the URL, so it just set them to be none, right? So in Python we have none, or like undefined. When that gets converted to JSON, it converts it to none. If I give the data here, such as data1 equals Hayden and data2 equals Millie, and I click send, then I get that correct, right? So I can actually see, like, I can interact with it. And you also feel it's a little bit lighter than web browsers in a way. It's a little bit easier to use. So I think I can save this somehow. Save. I'll call this 1. Save. So I've kind of saved this particular route here. And what I'm going to do now is if I want to call the second one, which is 2, then what I'm going to do is I'm going to change this method to post, right? Because remember how we said it's like get, post, put, and delete. And I'm going to change this URL to 2. Now I'm going to try and send this one. Okay, you see I just got like some kind of server error, right? So I'm like, oh god. So sometimes this happens with servers. Like if you have bugs in your code, you will get these kinds of crazy errors when you try and talk to your Flask server. And in general, you can go look at your terminal and it says none type object is not subscriptable. So the reason this has happened is because this to thing expects there to be some kind of data, but I didn't give it any. So let's give it some data. Yuval says, so the ARC client basically allows you to test your requests and responses in an easy and lightweight way. That is a perfect description of what this is. It is an easy way to interact with Flask. You will pretty much not use your web browser. You will use something like this. There are other tools as well. So the thing is that when you make GET requests, I said that you put those requests in the URL. Whereas when you make POST, PUT, or delete requests, you actually put them in the body. And you put them in the body as JSON. So see on this 2.1 here, I'm actually gonna I'm gonna set this to be JSON Visual Editor. Let's use the raw input. And I'm actually gonna put it in here, and I'll say that data 1 is Hayden, and data 2 is Millie, like that. Right, and we're familiar with JSON. Remember, JSON's just a string. And all we're doing is sending this string to the server. And when I click send now, I actually get a successful response back. So if we have a look here at what's happened, we have called the server on the URL /2. We've used a post method, and we've sent it a body, right, which is like the data. And you can see that what Flask has done here, like we've written this, is it's actually gone and taken that body and turned it from JSON. Think about this as like, it's a little bit like JSON.load. Do you remember how we learned that one in the last lecture? It's a little bit like taking the JSON string and loading it into an object. So data is now our object here. And remember, in Flask, you can print just like it's a normal program too. If I just put print data here, right? And my terminal's here. When I run this, it'll actually just print the data out on the terminal for me. So you can actually just debug it like a normal Python program. Like you don't feel like you have to be in the dark about this. You can actually just print variables like normal. So before you get overwhelmed with this, right, just because we're coming up in the last few minutes, there's a lot of we call this boilerplate, right? And boilerplate is a word to kind of describe code that just has to exist. It's like a formality. And there's kind of a lot we've talked about in the last hour. But the thing to remember is that most of how you'll be using this in your project is going to be copy and paste. Like in terms of implementation, it's like, oh, this is about as complex as it gets. Literally, like we've pretty much done most of the new theory here, and then we're just going to be like kind of revising it, etc. Cap says, how would you test post without the ARC client? You could use other clients, and there's other ways, but generally you use a client like that. You don't use the web browser is all I'd say. The other methods, which we'll very, very quickly touch on, because it takes a second, is put and delete. All use the same process where you pass the information in the body. So for all these kinds of requests, you actually pass information in the body except for get, where you pass it in the URL. So for instance, if I want to save this one as 2, save as new, right? If I want to use the 3 URL here, right, which is of type put, then it's the same kind of thing. This put method has to take in a body, which I've got here, body, right? And when I send that, I get a response here, right? And the response is this object turned into JSON and sent back. And then same thing, if I save that one as 3, because that's the one I like, I'll make the 4th one, which will be delete. And delete is /4. You can see it, it's of type delete. That's the URL, and it takes in this body stuff, which I have here. And when I click send, I get that response. So if I save that one as 4. I forgot to save as new. Damn it. Okay, that's all right. So all we're going to be doing for tomorrow and then large parts of next week is looking at these 4 different types of HTTP methods and how to call routes and stuff like this. So iteration 2 will be released tonight. We'll talk about it more in the lecture tomorrow, as well as talking more about web server stuff. And yeah, it's exciting times ahead. So I'll just send the survey out, and that's pretty much it on the first. So this will be part one. There'll be a second part of this lecture.